Today, the topic is knapsack problem using dynamic programming technique. So here, knapsack problem is a problem of filling a knapsack with n number of items, so that the objective of this one is to earn the maximum profit. That is the objective of a knapsack problem. So here a knapsack is a bag which will have a capacity of m. So that the items are filled in a bag such that we will earn a profit. Such that you will earn a profit. Uh, the constraint is all the items, sum of all the items weight should not exceed the capacity of the bag. Here, two types of knapsack problems, two versions of knapsack problems are there. First one is fractional knapsack. This is the first version. Uh, this problem is solved with the help of greedy technique. So second one is a 0 by 1 knapsack. This technique is used to solve with the help of dynamic programming technique. So here 0 by 1 knapsack means the items are indivisible, whereas fractional knapsack items are divisible. Items are divisible. So here 0 by 1 knapsack, 0 means the item is not taken and we cannot place the item into the knapsack. Cannot place the item into the knapsack. That is 0. 1 means the entire item is placed in the knapsack. Placed in the knapsack. So this is the 0 by 1 knapsack problem which will be solved by using dynamic programming technique. So here, when an item is removed from the knapsack, so here two criteria are there. One is item is placed in the knapsack. Another one is item is removed from the knapsack. When an item is placed in the knapsack, two operations are required to perform. So first one is knapsack weight is reduced by the item weight. That means at present, for example, the knapsack capacity is 10 kgs. Whenever an item is placed into the bag of 2 kgs, then the capacity of the bag is reduced to 8 kgs. And the second operation is whenever an item is placed into the knapsack, corresponding profit is added to the total profit. So these are the two operations whenever an item is placed into the knapsack. Same way, in some cases, item is removed from the knapsack. In this case also, two operations we are going to perform. So first one is capacity of the knapsack is increased. Whenever an item is removed from the bag, the item weight is added to the knapsack capacity. Same way, corresponding profit is reduced from the total profit. So both of these two are the exactly reverse operations. Whenever an item is placed, capacity is reduced, profit is increased. Same way, an item is removed from the knapsack, capacity is increased and corresponding profit is reduced. These two rules are also known as merging and purging rules. Merging and purging rules. So let us see one example. So this is the example. Here n is equal to 4, m is equal to 7. That means the capacity of the bag is 7. The capacity of the bag is 7. Number of items are 4. These are the corresponding weights and these are the profits. So before going to solve this knapsack problem, we will construct a table like this. So these are the values we are going to fill in various steps. First, we will draw an empty table. An empty table here, all of these values are not shown. All these values we need to calculate and fill. So this is the table. Here profit and weight. Profits and weights. So this is the profit for first item. This is the profit for second item. Profit for third item. Profit for fourth item. Same way, the corresponding weights you need to write here. After that, here capacity of the bag is 7. So that we will place the items, any items which will have less than or equals to 7 kgs. That's why here all the weights in increasing order shown here. Starts with 0 and ends with capacity of the bag. So this is the empty table. Here all the values we are going to fill. So these are the weights and profits. So first we will fill the first row. While filling the rows, this is the formula. While filling the rows, this is the formula. I indicates row number. W indicates column number. So here this is a row number and this is a column number. Whenever we want to fill the data, this is 0th row, 0th column, 0th row first column, 0th row second column and so on. So here first for first row, we did not calculate according to this formula. So why? Because the weight of first item is 1. So the weight of first item is 1. So that's why we are not able to place the item in the in the 0th column. Okay, that's why the profit is 0. So assume that if capacity of the bag is 1, then we will place the entire item in this bag. That's why we will earn profit 1. Same way capacity of the bag, we will place the entire item and we will earn 1 profit. The empty place of the bag will be leave here. Just capacity of the bag is 3, then we will place the entire item because the weight is 1. That's why we will earn a profit of 1. Same way 4, 5, 6, 7. So the first item 1 and profit is 1. So we place the first item in the entire row, the corresponding profit in the entire row. This calculation regards to first row. Same way, here we need to fill this second row. So while calculating, filling the second row, the weight of the second item is 3. So the weight of the, this is the weight of second item is 3. So we are not able to place in 0th column. That's why profit is 0. We are not able to place this 3 weight in the first column. So that's why we will not earn anything. The previous item is carry forward to here. The previous profit is carry forward to here. So whenever the capacity of the bag is greater than or equal to this one, then we will apply this formula and take the maximum value of the previous row or calculated value. whatever the maximum value, we will consider that one. So whenever the capacity of the bag is less than or equal to this one, the same previous values will be carry forwarded. Why? Because we are not able to place these 3 cages in one. That's why the profit is also we are not going to be earned. Here the entire item is going to be placed or entire item will be leaved. No fractionals are allowed. So here also 2 cages. We are not able to place 3 cages item. That's why the corresponding profit is come to the bottom. Same way here 3. So 3 cages, 3 cages. So whenever 3 is less than or equal to this one, then we will apply this formula. So here maximum of V of, so here this is I, this is W. So I minus 1 means 2 minus 1, that is 1, and W is 3. So V of 1 comma 3. After that, V of Ij comma W minus Wi, that is V of 2 minus 1 comma 3 minus 3. So here Wi means the weight of the item which we are going to be placed in the knapsack. That's why here Wi is equal to 3 plus profit of I plus the corresponding profit of this item. Corresponding profit of this item. Why? Because we are going to calculate here means the capacity of the bag is 3 and also we are going to place the item is 3. That's why the remaining capacity is 0. So here maximum of V13 comma V10. Here V of 13. This is 1, 3, 1. V of 10. Here 10, that is 0. Plus the profit of this item is 4, 4. So that's why the value is placed here. Same way V of 24, 25, 26, 27. All of these values we are going to be calculated. So take one more calculation, that is V of 2 comma 7. So here I value is 2 and W is 7. That means the total capacity of the bag is 7. Here the total capacity of the bag is 7. That's why here V of 1 comma 7. So I minus 1 comma 7, that is I minus 1 comma 7. This is the total capacity of the bag. The value of 1 comma 7 is 1 here. After that V of 1 comma 4. Why? Because we will take this one means the total capacity of the bag is 7 here. In 7 we are going to place 3 cages item. So that's why 4 is remaining balance. So the weight of 4 is kept free. That's why in first row 4 cages which item we are going to place here, the corresponding profit we will earn. That's why the profit of previous row is added to the current profit. So 1 plus 4. So these are the 5 is the maximum value. That means here we are going to place the first item as well as the second item. The first item profit is 1 and the second item profit is 4. All these two profits are added together to earn the profit. Total profit, that is 5. So this is the way of calculating second row. Then coming to the third row, so this is a calculation of third row. So here weight of third item is 4. That's why this third item is not able to place up to 3 columns. Why? Because here the weight is 4. So less than or equals to this weight we are not able to place. So all the previous values are carry forward to the down. So these are the values. Whenever the value is uh, greater than or equal to this capacity, we need to calculate. Why? Because the previous profit are the item which is placed here, whichever is higher, that value will be considered. So here the weight is 4, profit is 5. So we are going to calculate this value. That's why third row, fourth column. This is third row, fourth column. By applying the same formula, we will get a profit of 5. Same way 3 5 we will get a profit of 6, and 3 6 we will get a profit of 6, 3 7 we will get a profit of 9. Okay, profit of 9. So why? Because the capacity of the bag is 5 here, 7 here. So here the weight is 4. So that's why this item, entire item, we are going to place here. So corresponding profit we will earn is 5. Just check it, the value. Corresponding profit is 5, and capacity of the bag, that is M, is reduced by this item weight. So that is 7 minus 4, that's why 3. Okay. Next, the previous row, a weight of 3 item is here. Capacity of the bag is also 3. That's why this item is able to place in the knapsack. That's why the weight is reduced by the value, and the corresponding profit is added to the profit. That's why we will earn the profit of 9. So this is the process of checking whether we are going in right direction or not. At each and every step we will check it. It is a general problem. Then the final step is we are going to fill the fourth row. So here the fourth row is the weight of item is 5 and corresponding profit is 7. So whenever the item weight is 5, up to 4 columns, the previous values are carry forwarded to the bottom. So these are the values which will be carry forwarded. So we need to fill fourth row, fifth column, sixth and seventh. All of these 3 columns we need to calculate. Okay, so 4, 5. So maximum of I minus 1, that is 4 minus 1 is 3, and weight of this particular item, that is 5. After that, I minus 1, 3, comma, weight minus WI. So we will check the weight is 5 here. Entire 5 I am going to place here. So 5 minus 5 is equal to 0. So that's why V of 3 comma 0 plus 7. Here this is the third row. 3 of 0 is 0. 0 plus 7. That's why maximum value is 7. Same way these two values are also calculated here. Okay, the problem is completed. After that, the question is, what are the items we placed in the knapsack? By seeing this table, we are able to tell what are the items placed in the knapsack. So how it is possible? So here the maximum profit is 9. This is the maximum profit is 9. So check it towards up until the value will ends. So here this is 9, it is the maximum profit. So this value we will check it towards up until end. So it will close at third row. So it will close at third row. So here the item 4 is included and the corresponding profit we earned is 5. Sorry. So here the item 4 is included and the corresponding profit we will earn is 5. So item number X1, X2, this represents 4. So here also 9 and in previous row also 9. That means there is no change in between these two rows. That's why this item is, it clearly indicates that this item is not included in the bag. Why? Because this profit is already earned in the previous row. It clearly indicates that there is no change in this row. That's why this item is not added, included in the knapsack. This is 0 and x3 is 1. That means x3 is included, and we will earn the profit of 5 here. So the next question arises, what are the profit of 4? What is the profit of 4? So here the capacity of the bag is 7. Whenever this item is placed into the bag, the corresponding weight, that is 4, will be reduced and the bag capacity remains 3. Bag capacity remains 3. That's why we will check it the third column of this row. So of this row, third column of this row. So towards up, it will be checked where it is ended. So towards up 4, it will ends at the second row. It clearly indicates that the second item is placed in the knapsack so that the corresponding profit is added to this profit. Second item profit is 5, existing profit is 5. Second item profit is 4, existing profit is 4. So 5 plus 4, we will get 9. And in previous step, bag capacity is 3. Here x2 weight is 3, that's why 0. Okay, 0 weight. That's why we will see 0 towards up here, 0. That means we are not able to place the first item into the bag. Why? Because first item weight is 1 and the bag capacity is 0. That's why we are not able to place the item into the bag, knapsack. So here these are the values. X1 is not placed into the bag. X2 is placed into the bag. X3 is placed into the bag. X4 is not able to placed into the bag. So whenever X2 and X3, both of these two items are placed into the bag, X2 is having a profit of 4 and X3 is having a profit of 5. So all of these two profits are added together uh, to complete the process. So 5 plus 4, the total profit is 9. And once again check whether the bag capacity is sufficient to place these two items or not. So total bag capacity is 7. Total bag capacity here is 7. Here we are going to place x2 completely. So x2 weight is 3. That's why bag capacity remains 4. And we will place x3. So weight of x3 is 4, 0. So whenever we place a second item and third item into the knapsack, we are not able to place any more. That's why x1 and x4 are not able to place into the knapsack. So the solution is this one. This is the solution. X1, x2, 1 minute please. X1, x2, x3 and x4. X1, x2, x3 and x4. So this is the formula. X1 is equal to 0, x2 is equal to 1, x3 is equal to 1 and x4 is equal to 0. So maximum profit earned is 9. So all of these steps are explained clearly in the previous slide. So this is the knapsack problem. This knapsack problem is also known as 0 by 1 knapsack. Why? Because 0 by 1 knapsack means it will not allow fractionals. So we will take the entire item if possible or leave entire item. But it is not allowed to place a fraction of item as in the greedy approach. This approach is dynamic programming approach. In this, fraction of items are not allowed. That is the important point.